All right, you 12s. Thank you again. Day one. So many technical issues, but let's begin again. Here we go. So, yes, you are right. This means and. It is the intersection is the proper word. And it means when two shapes overlap. Very good. So group A, group B, they overlap. Whatever that overlap section, that's what intersection is. Union. You can think of it as together or unite. Means that you color all A and B. That's one of the common things that students get confused. When you say union, you literally group all of A, group all of B. Even if I do something like this. So, if I say not A, union B. What a lot of students think is if this is group A, and we say not A means everything outside, right? And then we say group with B, so union with B. Students then only color this section. But they leave that because they said it says not A. But when you say union, it means, yeah, we have not A already. Then B, you got to make sure you color all of B as well. So that means that section does get colored. That's one of the common misconceptions when we say union. It actually just means group them all together. It's almost like saying this is class A, class B, we put them all together. You don't miscount anyone. Yeah? So that's union, subset. This means subset. Subset, so like we said before, this is group A, group B. So you would say A is a subset, B is a subset of A. So it means B is a part of A. Okay? Backslash. What's backslash mean? Let's go Vibber. Exclusive, very good. Not forward slash. In the past, you used to get penalized if you use the forward slash. Nowadays, apparently examiners are more lenient with it, but backslash is the proper way. Okay, so backslash means excluding. And this one's pretty simple. The symbol means what? Let's go with Jacob. Null. Very good. Null is not the same as zero because zero is an actual number. Null means there's nothing. So sometimes we write the subset like that. So it means in this set, we've got nothing. So you don't put zero there. Okay? All right, let's have a look at other symbols that you might see more often. R, which means all real numbers, any numbers that you can think of. What is Z? What's Z stand for? Let's go with Adonis. Integers, very good. What does integers mean? Let's go with... Sorry, I forgot your name. What was your name again? Aryan. Aryan, what is integers? Or what are integers? Yeah, just whole numbers. Whether it's positive or negative, it's called whole numbers. So when you see that, it means your answers can only come from whole number sets. What is Q? Let's go with Phoenix. What does Q represent? That's okay. I'm just revising. So if you don't know what that is, that's okay. Krish, do you know what that is? Rational numbers. And what does rational numbers mean? Can I please have Jason? It can be divided or ratio. So think about a fraction, but technically the proper, you can write it as a ratio of integers. So if you break down what I just said there, ratio means you can write it as a fraction. So A over B, that's a ratio, A to B. But A and B have to be integers, meaning that they have to be whole numbers. Okay, so if you think about fractions, usually say 1/3. That's a whole number, that's a whole number. This together is called rational. Okay, that's rational numbers. Anything outside of that, outside of rational numbers, so if you think about the number set here, Z, Q, R, anything outside of Q, anything that's not a fraction is what? What's some examples of not a fraction? So what's irrational? So if you got rational means like fractions, ratios. Pi. We use the symbol pi because technically that number's infinite. We can't write that as a fraction. We can't write that as a nice definite value. Root 2. Those are irrational numbers. Those goes on forever. Those are decimals that you cannot rewrite as a fraction. So that's why it doesn't fit into Q. So anything that doesn't fit in Q is called real. That's your number set. Out of curiosity, anyone know what N stands for? Natural numbers. And what does natural numbers mean? Yeah. Very good. Those are called natural numbers, which is whole numbers as well, but it's different to Z because it only includes positive. It doesn't include negative. So if you think about the way that you've been learning number systems, that was primary school. Whole numbers. Year 7. Merging into 7, 8, and then merging into 9 when you start doing surds, fractions. That's where Q and R starts coming in. And R specifically 11 and 12. Okay, so that's your sort of journey of learning the number systems. Obviously, we've got one that we haven't actually worked with, which is C. What's C? Complex, which best students will do. Methods we don't. That's why I didn't put it there. Okay? N is natural. All right. What I wrote there means is a subset of Q, and Q is a subset of R. So hopefully now you can understand that language. Cool? Some names for you to know. This is called standard notation, which is what most students do when they get to year 11. This is what you're used to. At year 12, we prefer you to use interval notation, which combines with sets. Okay? You don't have to. You can still use standard notation, and it still be acceptable. But I'm just saying that when you read the exams, you'll find that they're using interval notation. So what was the point of exercise 1A? What's the essence? Learn to use these. That's what they're trying to say. So all of that wasn't about you memorizing this. It's about you being able to read that. That's what. Okay, so let's do interval notation for standard B. Now I need to use it as interval notation. How do I say from -3 to 4 is what X can be, but not inclusive? How would I write that? What was your name again?
Zach.
Zach. How would I write this as an interval notation?
You go some like curly brackets, and then you go -3, almost, and then 4, and then curly brackets.
Good. This is actually called open brackets. Curly is this one.
Oh, yes.
That's okay. So I'm just fixing your language. So this one is called curly. When do you use curly? Specific time. You'll get it to you start using it in chapter 9 and 10.
When you're talking
Sets. Or yes. A better way, just so that you understand, is list. When you have to list number of elements, which is in probability. Okay, so when you do probability from chapter 9 in year 11, that's why you use this symbol. This symbol is only for listings. You want to say what's wrong with my pen? All right. I don't know why. No. Why? Yes, ChatGPT has improved. It's actually good to use, although you should double check the answers. Here and there, I find that it doesn't answer exactly, but most of the time, it's a nice. Yeah, most of the time, it's pretty good.
Yeah, that's what I was told. Like negative X squared plus negative X squared plus 1. You
You got to visualize it.
You have to visualize it.
Part of methods you have to visualize, or you have to break the equation into its pieces. So, for example, every time you square a number, it has to be positive. But then if you put a negative in front of it, that means every number has to be a negative. And then if it's all negatives, and you minus 1, then no matter what that negative number is, yeah.
I wish we could use matrix transformation.
I did kind of forget how to do it though.
Yeah.
It's just like
This is killing me.
just not yet. Vectors is like it's the put that in.
Image of the function is
Not a
like the
pre-image of
like the pre-image is like the original function. So it's not like extra.
pre-image of a
Oh, I think
Sorry, team. I've given up on OneNote for now. I think my computer's just too lagging with all the uploading. So I'm just going to use PDF now. I'm just going to write on PDF. And we're going to jump into 1B pretty soon, just so we can get through an essence of 1A, 1B. I don't think I can get to 1C. We'll probably do it next week. All right, let's do 1A again. So let's just fill out a couple of things. So what's the essence of 1A? I wanted you to, or at least what it wants you to do, is you need to be able to read these notations. So the questions are getting you to read, do you know how to break up the elements or the sets based on the notation they're giving to you? First one, yes, we were talking about just now, we were saying the answer was correct. We say X is an element of -3 to 4. I then tangented off a bit and said you only use curly brackets when you're listing. So for example, if you said A is rolling a dice, dice can have 1, 2, 3, 4, 5, or 6. That's when you use curly brackets. Okay? Next one, I'm just going to fill that out so that you can see. So we're saying from -1 all the way to 2 inclusive. So we use a closed bracket for inclusive, open bracket for not. Okay, and the last one here, which we should know, -infinity to 4. Remember, with infinity, you do not use closed brackets. It has to be open brackets. Okay, we can't include them. All right, so that essentially just means x less than 4. Inclusive. All right, so essence of 1A, what do you take out of it? It's just being able to read the notation and utilize interval notation. If you've got that already or you feel pretty confident, move to 1B. Let's go to 1B team. 1B. All right, 1B is touching base on what you learnt about functions last year, and that links to 1C as well, but let's see how far I can go in like 20 minutes with you. So domain and range. Domain is all the x values that you can see in a graph. So part of methods, you need to be able to tell from looking at a graph or an equation what your domain and range is. Function notation in part 1B, so exercise 1B. The other thing you need to get familiar with, if you haven't started using this notation last year, this is called function notation. Can I get a show of hands who have been able to use something like this? So that's an arrow. Can I get a show of hands that you're able to read this, you've used it or can use it, and you can visualize right now what this looks like? So if I asked you, what is the domain and range for this question, that's what 1B does. Okay, so if you understand it, that's the essence of 1B. All right, but that's what 1B wants you to do. Can you write this notation? Can you visualize it? And can you see it? Now I'll break it apart for you to see if you haven't actually practiced this before. This part here tells you the domain. So it's saying on the x-axis, we only have -1 to 2, both inclusive. Okay, so that's the domain, the first number. The first letter just means the letter of your function. So it could be g of x, h of x. That's what that letter means. Maps onto R just means that the numbers come from the real number set. Okay, so we talked about that circle. Just comes from numbers of R. F of x equals x squared. What type of function is this? What's this function called, Ishan? Parabola. So, I'm visualizing a parabola. But this x squared graph, which touches the origin, has a restriction. It says from -1 to 2. So on the x-axis, I can only have from -1 to 2. So the graph must only start at this point on the graph when it's -1, and it's sketched all the way until I get to 2. That means that red part that I drew before, that's gone. This is the restricted part because I said domain is -1 to 2. So if I asked you in this question, imagine this was the question as a quiz, and I said, state the domain and range. That's usually 1 mark. Okay, so 1 mark, state the domain and range. What would you say? Those are usually notes that I write, and then you can do your own practice in, because what I don't cover in here is any applications or any problem solving. So sometimes in exercise 1A, C, you might find some problem solving. If you don't find them, and you do it as in your own learning. So as you scan through it, if you feel that you've already understood it and you can demonstrate those skills at a higher level, move on. Yeah, so I don't expect you to go through all this, okay, and then do all those questions. I don't need that. When you upload your homework, what I'm looking for is what skills can you demonstrate. Obviously, if you aren't demonstrating any, and why don't I want you to upload these ones? Because usually in class, I go through the notes with you. So I can't tell who can do it and who can't do it. So what I need to know is from now until the end of the year, you just need to consistently show me what can you do. So the more questions you show the steps, the more understanding you show, and the quizzes will then should prove to me that you actually do know that. If I have a discrepancy that the quizzes don't match with what you are sending to me, that's when I ask you to come up and show me. Okay, so that way I just need to know and verify that by the time the end of the year, I'm confident where you're roughly sitting at on the curriculum. Does that make sense? So whatever you do, as long as you demonstrate it to me and you upload it to me, that's how I know what you know. Okay. All right, so domain and range for this question. Domain is obviously right here, -1 to 2. What is the range for this question? Let's go with Krish. What's the range? 0. Okay, good. So we can see the graph here starts at 0 for the y value. So on the y-axis, it starts off at 0. That's the smallest value. So the highest value, clearly, that's the highest point. So at this point here, it's 2 for the x value, but I don't know what the y value is. But Krish has already done that. We already know the function was when x is 2, 2 squared gives you 4. So that was implied, and all of that was needed to be done on yourself. So the question, when they give you this line, you need to be able to read the notation, and then I ask you the questions, what's domain and range? That's what exercise 1B is. Make sense? Okay, so 1B, that's what you're taking out of it. 1B, domain and range. So if you said domain, you should say domain, or you can write it as x element of -1 to 2, inclusive. Range, y is an element of, and in this case, it is inclusive of 2, and it goes all the way to 4. So 2 to 4. If you struggled with what I just described, either sketching the graph or visualizing this, that's what 1B is. So spend your time making sure that you've ticked off that skill. Okay? They will throw in all different types of graphs. They'll give you a straight line, a square root function, everything that you did last year. Same idea. Sketch the functions and then figure out domain and range. That's what 1B is. Cool? All right, so these are just the examples for you to try out and have a look. Reading notations, sketch the graph, work out domain and range. Okay, that's 1B. Anything else from 1B? No? Okay, this last 2 pages from 1B. So first part of 1B is identifying domain range. So that was a typical question that you could do. Next bit, Last year, you may or may not have remembered this. What is a function? Now, before you know what a function is, you need to know what a relation is. Can I get a show of hands who know what a relation is? Okay, 1, 2, 3. Cool. For those who don't know, it just means set of coordinates. What does that mean in plain English? See, on a Cartesian plane, every time you have any coordinates, see those coordinates there? That's random. 1, 2, 3, 4, 5, 6. That's called a relation. That's a collection or set of coordinates. But when you happen to have a set of coordinates that follow a certain description, then we give it a name. So for example, if I gave you this, that set of coordinates, what kind of pattern is that leading to? What's this called? Starting with L? It's linear. Very good. So this is called a linear function. Notice the language we use, linear function. You may have another set of coordinates that looks like this. What's this one? Square root function, right? But notice that the language that you learnt in year 11 was called function each time. What is a function? In order for it to be classified a function, every x coordinate, there is a unique y coordinate. So you look at these two examples I just drew. There's a set of coordinates here, so it's a relation. Set of coordinates here, it's a relation. But what makes it a function? Right here. So no matter which coordinate you pick, even if I pick this one, that has one x value, and it also has one unique y value to it. That is the description of what a function is. This is why a quadratic, let's have a look at a quadratic one. So this is the set of coordinates for a quadratic. Now notice what happens here. If I pick this coordinate here, for this x value, you have one corresponding y value. It's not two. Yeah? Even though this other x value has the same y value. Doesn't matter because every single point has only one x, one y. Okay, so this point only has one y. This point only has one y. It doesn't have two y's. Okay? What's this picture? This picture means when you put in an x value into the function, and if you only see one y value, that's what we call a function. Okay? So in our case, if it's a quadratic, 2 squared gives you 4, negative 2 gives you 4. But you see, no matter what number I put in, it only spits out one value. What's an example where you get two y values? I'll draw one for you right now as one. And I do want you to copy this one down so that you remember the difference between function and relation. What's one where if I sub in x and I'm going to get two y values? Here's an example. This relation. Anyone know what this graph looks like? Or what that's called? Might have seen in year 11 if your teacher's shown it to you. It is the inverse of parabola. Yes, but it's a special name for it. Or if you think about it, what's this top half? Square root. What's that bottom half? Square root, but it's a negative, yeah? So technically this is a positive square root function and a negative square root function. Notice the language I'm using. I said function. Top half is a function because it follows 1x for 1y. But technically, what happens if I ask you, what's the square root of 9? What's the answer? Plus minus 3. It's not just 3, yeah? So technically, you're meant to have plus or minus 3. So it means, for example, in this machine, does it pass the function test? If I put a 9 into the machine and the function says square root 9, your y values could either be a positive 3 or negative 3, which is shown in this graph here. That's why we call this specific graph not a square root function, We call this when x is 9, you can get a point where the y value is 3, or you can get a point where the y value is -3. This is called square root relation. And one of the exams in the past, that's what they tested. They said in the exam, they said, sketch the square root relation, not square root function. And because they wrote relation in there, they bolded it as well. Students didn't know what a relation meant. So they drew a square root function because that's what they're used to. But when they say relation, this is what it looks like. Because you can have both the positive and the negative, because you can have two y values, because that's a relation. Relation is a set of coordinates. But when they say function, that can't be a function, because for one x value, I end up with two y values. So this is a square root relation. Okay, so if you type on your Desmos, usually they only sketch the function component. You have to tell it that to be a relation for you to be able to draw a relation. Okay, but that's the difference. So hopefully that will help you understand now 1C, exercise 1C. Actually, how much time? I only got 6 minutes. Maybe I'll do 1C next session. But I want you to keep that in mind, what I said, because next session I'm going to then help you memorize the types of functions you have. Yeah? All right, let's finish off by just testing your knowledge here. All right, let's have a look. Is the first one, y equals x, is this a function or a relation? Function or relation? Function. Now, in year 11, we said there was a test to figure this out. How do you test for a function again? Vertical line test. Why does it work? Because when you do a vertical cut, you're testing that for one x, there's only going to be one y value. Whereas this one, if I did a vertical cut, can you see when I do a vertical cut here, cuts twice. If it cuts twice, I'm going to have two y values. That's why we do a vertical line test, to see if it's a function. If it cuts twice, means you've got two y values, not a function. So for all of these, if you want to know if it's a function or not, we do a vertical line test to figure out that definition. No, not a function. Relation, because for one x value, so say at 10, I have two possible y values. So VLT for vertical line test means, is it a function? Write that as part of your notes. What about horizontal line test, HLT? What was that for again? One-to-one function. Very good. Now this is for 1C. So when we get to 1C, for those who are sort of ahead and was comfortable with 1A, 1B, you can go to 1C. Horizontal line test. If I did this, yes, it's a one-to-one. If I did this one, it's also one-to-one. But that's what the exercise do. But if I'm asking you now, why do we do a one-to-one? Why do we want to know if it's a one-to-one? What's the reasoning? To find the inverse. Okay, so we'll talk about inverses later on. That's one of the properties. Inverse cannot occur unless you have a one-to-one. Okay, that's for later notes, but if you want to write it down, you can. Horizontal line test tests if it's a one-to-one. Why do we want to know if it's a one-to-one? Because we want to know, does it have an inverse graph? Inverse graph can only have a one-to-one. Cool? Again, I apologize for today's lesson. It is not usually how I run my lessons. We had the first half of housekeeping, and then I had some tech issues with along the way. But usually, I would be able to get through the notes more clearly, and the videos would have been recorded, and you would have had a good set of notes for you to practice. Okay? But today's 1A, 1B. Next lesson, which is next week, we 1C. We can start packing up. But that's the idea. So Essence 1A, learn the notation, read it, learn how to use it. 1B, domain range. So you have to be able to sketch, read the notation, and determine if it's a function or not. 1C is then breaking it up. Okay, so 1A, 1B. If you can go to 1C, fantastic. If you can't, don't worry. Next week I'll cover it with you. Okay? Thanks, team. Welcome back. And yes, it's going to be an intense year, but that's how it is. So try to keep afloat. Let me know if you have any troubles. Let's pack up. We've got 2 minutes before